Hello everyone, my name is Kiran Babu Bhattrai and I am going to solve a problem related to finding the inverse of the function. So here I begin. We'll be talking about several things in this session. We'll learn the definition of an inverse function. We will learn the example of an inverse function and we will verify the inverse function. So now let's begin it here. By the definition of the inverse function, what does it say? An inverse function is a function that reverses, you should remember the word reverses here, that reverses the effect of another function. So if you have a function f, let us consider a function f that takes an input x. So in this function we are going to put the value as an x and will produce the output y. So when we put any value of x in the function, that will obviously gives us the value of y. So putting the value of x will give us the value of y, so y will be equal to fx. So then the inverse of the function is denoted as f inverse x, so that will be the inverse of the function. F inverse x would be the inverse of the function, and then in this inverse of the function, if we put the value of y, if we put y value in the inverse function, then that will give us the original input x. So x comes to be f inverse y in the inverse function. So that was the definition of the inverse function. Now after moving to the definition, let us see an example here. Okay, so let us consider this as a function. The function is fx equal to 2x plus 3. So now in this function we will replace the value of x with 1 to get the value of y. So we, in this way, we can say that f1 equals to we can say that now f1 equals to 5. So similarly, when we put x equal to 2 in this function, we will get 2 into 2. Yeah, if we put here 2, then this gives us 2 into 2, 4. 4 plus 3 would be 7. So that is why f2 equal to 7 here. So similarly, f3 is equals to 9. So this thing, all set of things can be written in an ordered pair. So on writing this in order pair, we'll get 1 comma 5, because when we had put 1 we had got here 5. So 1 comma 5, 2 comma 7 and 3 comma 9 is the order pair of the function. Now the inverse of the function will be just opposite of this function. So the inverse of the function, that is denoted by f inverse this way. This is the way we rewrite the inverse of the function, and then this comes to be 5 comma 1, 2 comma 7 and 9 comma 3, just the opposite of these things. So now we will talk about of solution of a function. Let us consider there is a function f(x) equal to 3x plus 5. This is the function. So now let y equal to 3x plus 5. We have assumed y equal to 3x plus 5 here, and then we will now interchange the role of x and y. So this x, wherever there is x, we'll write the y. In place of this x, we'll write the y. This x will be substituted by y, and this y will be substituted by x. So by doing this, we'll get here x equal to 3y plus 5. Here was y, and we got x in place of y. Here was x, we get y in place of this x. So x equal to 3y plus 5 will be the answer. Now after this, we can write 3y equal to x minus 5, just rearranging the term, and then we can get the value of y, that comes to be x minus 5 all divided by 3. So thus the inverse of the function comes to be x minus 5 divided by 3. Now this was our solution. Now we'll try to verify how is our solution correct. Let us consider this was the function that we had considered, fx equal to 3x plus 5. Now let us check the solution of this function, fx equal to 3x plus 5. Let us put several values of x in this function. We can put any values of the x here, so I'm putting several values of the x. So on putting 2, we'll get here 11. So just put the value of x as 2. 3 into 2 plus 5 is 11. Similarly, when we put 3, we'll get here, when you put 3, we'll get here 3 into 3 plus 5, 14 as our answer. And just the same way, when you put 4, we'll get 17 as our answer. And when we put 5, we'll get 20 as our answer. Now we'll re-put the value of x, which was the value of which was obtained earlier in the inverse function. So what I mean to say is that the answer that we had obtained earlier will be put in our inverse function. So let's see what will happen. So f inverse 11, the 11 that we had obtained here, I'm going to get the same 11 here as well. So the 11 we had obtained here, will be putting this 11 here. So f inverse 11 would be 11 minus 5 divided by 3. So f inverse 14 would be 14 minus 5 divided by 3, that will give us 3. You can see the answers are reversing. The answer that we had got earlier, 11, if we put that 11 in the inverse function, we'll get the original value of original value that we had put earlier. So here you can see here, this, let me drop everything. The 2 that we had put earlier, it had given us 11, and the 11 that we are putting it now is giving us 2. So this shows that our answer is, like, the answer of inverse is correct. So just doing the same thing here, the 14 that we had obtained earlier, we will put that 14 again in this function, and will to get the same value of x that we had got earlier. So the same thing would be for f inverse 17 and f inverse 20. So now this can be shown in an arrow diagram this way. So these are the values of x that we had put earlier, these are the set of values of x that we had put earlier, and then now what values of y we will get here now. So the values of y are already obtained here. So the values of the y we obtained here are 11, 14, 17 and 20. So this can be this is x, and this one is fx. So these are the values we had got. Now this is the arrow diagram of the original function. Now what would be the arrow diagram of the inverse function? The arrow diagram of the inverse function would be exactly inverse of the original function. So this is how we have verified the inverse function. And thank you so much for your time, and you can give me the necessary feedback. Thank you. And you can get more updates here, a few links.